So this lesson is about what the value of I is and how to work with it. So we have these numbers called imaginary numbers. So I represents imaginary numbers. It's actually more accurate to call these invisible numbers because they're not actually made up numbers. They are values that are generated based on certain types of math that you can do. Okay, so I itself is generated from looking at a negative square root. So when I'm looking at I, what I'm saying is that if I have a square root of -1, that is a value that cannot be evaluated. So it's an invisible set. I cannot find it. I cannot evaluate it. Essentially, it's sort of impossible to look at. So what I want to do is be able to see it. So I'm just calling it I because then that's easier to look at. So for example, if I have a value of radical -16, all right, then I can say, okay, let's look at that. And what I'm going to do is split that up into the number, the regular number, which is 16. And I'm going to multiply that by the square root of -1. So I'm pulling that radical negative out by itself because this 16 here, I can look at and evaluate that. That's just a regular radical, and the square root of 16 is 4. And so I have 4 times the square root of -1, and that's as much as I can do. Now, this square root of -1 is just kind of weird to look at. It's a little stressful, so we're just going to define that. And what we do is we define it as a value of I. So it starts looking like a variable, which makes it easier to work with when we're trying to do math on it. So for I is how I would do this. So looking at my problems down here, if I look at A, there's my radical negative. So I can think of that as the square root of 64 times the square root of the negative. So there's the negative. Okay. And then I look at the square root by itself. So 8, square root of 64 is 8. And I put I for the square root of -1. And then that is my answer. Now, if I have a not perfect square like 12, I do the same thing, radical 12, because that's what I can simplify and evaluate. The negative, then once again, I can just put in as I, all right? So 12 factoring is 4 times 3. 4 is 2 times 2. Make sure you understand I'm not using the 4. So then looking at it as a square root, what can I simplify? The 2's come out. 1, 2 escapes out. And then I have the 3. So simplified, this is going to be 2 square root of 3. And then it's imaginary set. So there's an I on that. And then that is my answer. Okay, so quickly what we want to do is just define what imaginary is. Imaginary is any number that has I attached. So all the regular numbers, and then if I stick an I on the end, so 2I, that's now an imaginary number, -6I, 3/4 I, all of those are now imaginary. So there's a whole imaginary set of numbers. And essentially they're all numbers that are multiplied by the square root of -1. So any number I can pick, so some value, and then if I'm multiplying that by the square root of -1, it is now in the imaginary set, and that's what all of these numbers are. If I'm looking at a complex number, Essentially, a complex number is specified as a real value and then adding or subtracting an imaginary value. So 2 plus 4i, negative 6 minus 3i, 10 minus 7i would all be a complex numbers. Okay, complex itself contains all of the numbers. So I can write any number as a complex number if I need to. So on the real side, if I have, say, the number 6, if I need to stick an imaginary piece on there, I just say plus 0i. So now I have written it as a complex format. On the other side, if I'm looking at an imaginary number, the real part comes as a 0. So 0 plus my imaginary piece, like 6i. All right. So any number can be written as a complex number. All right, because as mathematicians, we would like to be able to use one giant bucket. Okay, so now what we would like to be able to do is add or subtract complex sets. So they work a lot like polynomials. If we're taking one complex number, 4 minus 3i, subtracting a second complex number, negative 2 plus 5i, we want to remember that this negative actually means subtract the whole number. So we're going to want to distribute that negative. So 4 minus 3i, distributing the negative, I'm going to end up with plus 2 minus 5i. And then I combine the real parts, which would be 4 and the 2, would give me 6. And the imaginary parts, minus 3i minus 5i, so minus 8i, and there is my new complex number. Same idea on the next problem. I have minus, that's set, so I distribute that negative. 5i, distributing the negative gives me minus 1 plus I. Negative of a negative is a positive. Then combining the real parts and the imaginary parts. So the real part happens to be negative 1. And there's only one real value, one regular number, so negative 1. And then my imaginary parts are the 5i and the I. So I combine those together. And I get plus 6i. So that's subtraction. If I'm looking at here at addition, addition is just do what it says. So nothing changes. 2 plus 5i stays the same. Adding to 1 minus 3i. Again, real parts and imaginary parts. Real parts are 2 and 1. So that is 3. Imaginary parts are 5i and minus 3i. So that will be plus 2i. And then that is my final answer. So why is I squared negative 1? So what we want to remember is that I itself is defined as the value of negative 1, which is a value we can't see, but is a value that exists invisibly. So then I'm squaring this. So if I square I squared, that means what I'm really doing is squaring the square root of negative 1. So what happens with squaring a square root is that square roots and squares are inverses and opposites. So what's happening here is that the square and the square root essentially cancel each other out and reduce each other. And so when you square a square root, they cancel each other out, like adding 2, subtracting 2, and you're left with what is inside that square root. In this case, you're going to be left with -1. So this is a fact that you need to know. So what I want to be thinking about then is I'm going to look at my numbers. So here I'm going to pull the numbers. The regular numbers are the 9 and the 4. And then what do I have over here is a -1. And there are 2 of those. So this value then becomes squared. Because I'm squaring it, what I'm going to get is then the square root of 36 here. This is going to turn into -1. So the square and the square root reduce each other. And then I'm left with square root of 36 is 6 times -1. So my answer on this one is -6. On the next one, the same idea applies. I combine my numbers, which are 3 and the 5. I pull my negatives out separately. Square root of -1. I'm multiplying it by itself, so it's squared. Once again, the square and the square root reduce each other, because that's what that does. And I'm left with square root of 15 times -1. Generally, regular numbers go in front, so final formatting would be negative square root of 15, because square root of 15 does not reduce. So then that is my final answer. So what do we do when we're multiplying values with I? You treat I, first of all, just like a variable. So if I'm looking at A, I multiply the numbers, -2 and 7, so -14, and I multiply the i's just like regular variables, and I get I squared. What I need to remember is that I squared is really -1. So this turns into -14, and then I squared becomes -1. So my final answer here, 14. Same idea on B. Bring your numbers together. The numbers are the -3 and the √5. So -3 √5. I times I squared. So now what? -3 √5 does not simplify, so I leave that like that. I squared is actually -1, so I replace it with -1. Now I just multiply my numbers again, so the -3 times the -1 becomes +3. So 3 √5. Final answer. On D, I'm multiplying 2 terms. Now this is a distribution set, or you can even do a box on this. Let's do a box on this one. So here's my box. First complex number down the side. This works just like regular distribution because we're treating I like a variable. Second number across the top. I then multiply into that. So 7 times 9, 7 times 9, 63, 7 times -8i for my top right box, -56i, 3i times 9 for my bottom left box, 27i, 3i times -8i for my bottom right box, negative 24i squared. Then I'm remembering, or I'm doing, that I squared is actually negative 1. So this part here is actually positive 24. So the I squared is going to change the sign. So it's not negative 24 times negative 1. I'm just going to write it as positive 24. And then I'm not using this anymore. So this box has now become 24 instead. So I'm using the 24. Now I just add my like terms. Where are they? First like term set, 63, 24. Those are my regular numbers. I add those together and I get 87. Like terms are I, so there's an I value, there's an I value. So negative 56 plus 27 minus 29i, and there's my new complex number. Since these are actual number values, so I multiply two complex numbers, I should get another complex number. On E, first step is to expand. 2 minus I times 2 minus I, because of the fact that it's squared. Then I distribute. So distribute through on the 2, 4 minus 2i. Distribute on the negative I for the second set, negative 2i plus I squared. I squared is really negative 1, so that replaces with negative 1. Then I have 4 minus 1, so a final answer of 3 minus 2i minus 2i. So the imaginary part of this will be minus 4i, and then that is my final answer. And so now I know how to add and multiply complex sets. Always remembering that I squared, if you end up with I squared, it equals negative 1. Make sure that you have that always happening.